In this video, we're going to look at the concept of a harmonic mean. We'll see how to implement it in Python, and we'll also see why it makes sense to use it in certain scenarios. Okay, so here's our situation. An absent-minded professor, who might that be, recently got to his classroom at Kenmore Classroom Building, KCB, opened his backpack, and then realized he did not have his laptop charger. Needing the charger for class, he ran 1 mile, mostly uphill, to 1010 Commonwealth Avenue. He maintained a speed of 2.2 miles per hour for this run. Once he got there, he grabbed the laptop charger and ran back downhill to class at 4.2 miles per hour. So note those two different speeds. Of course, it's easier to run downhill. This is actually pretty realistic. For this absent-minded professor's journey, what was the harmonic mean of his running speed? Well, we can just calculate a harmonic mean in a pretty straightforward way here in Python. So we'll do that first. And you have the import statement here from the statistics library, and the function is appropriately enough named harmonic mean. And we simply have to just pass in those two data points. We have the two speeds, and we know that the distance was the same there and back. And we get this number, this 2.8875. And I don't want to just end there and say, well, ta-da, there it is, end of story, because something you might be wondering, and I think it's a really good question if you are wondering it, is why didn't we just use a regular mean? Like, why not just add 2.2 plus 4.2 and divide by 2 and just get 3.2 and call the whole thing good? Well, if we did that, that so-called regular mean is also known as an arithmetic mean, where you just sum up the various elements and divide by the number of elements. The reason that won't work here is because the absent-minded professor spent more time moving at the slower speed. You can think about why that is just purely intuitively. Imagine yourself walking to a certain point and then sprinting back from that point. You spent more time on the way there because you were moving at a slower pace. And so we need something that adjusts for that or deals with that. And let's try to break it down intuitively first. Let's go back to the equation of distance equals rate times time. So we know from the given information up above that the distance is 1. It's 1 mile. And we also know that these speeds are expressed in terms of miles per hour. So in both cases, the missing element in the d equals rate times time equation is time. And so we have enough information with either of those to solve, because we're just missing one. Just one thing. We have one unknown in each equation. So we can store those here as time up and time down. So let's take a look at time up and time down. So we have time up and time down expressed as parts of an hour. So just long numbers there. I promise not to read those, but those are the two times. And so we can sum those here. And what we're going to see here is that the rate times the sum of time up plus time down. And let me just be more proper with the notation. Aha, very much better. Okay, so now that that's expressed that way, and of course it's done correctly in the code cell, which is the one that really matters, we can do this. And so we know that the total distance, the cumulative distance, is 2 because he ran up and he ran back down. And we have the total time. What we don't have is the rate for that collective period. And note what this number is. 2.8875 is exactly that number. So that is the harmonic mean. So seeing it that way might make it more intuitive. If you just want to know the formula for harmonic mean, which is very handy to know because it'll work even if you have more elements going on, and it would be more painful to break them down with lots of separate equations as done above. It's just going to be n. N is just the number of periods. And then that's going to be divided by the sum of the reciprocals of whatever rates are involved. And so that is an errant minus sign that is now cleaned up. But taking 2 and dividing by the reciprocals of the two rates yields 2.8875, which once again brings us back to the harmonic mean for this absent-minded professors running journey, scrambling up and down this 1 mile long hill to get the laptop charger for class. So thank you very much for tuning in and checking it out. Don't forget to like and subscribe. And if there's any particular content that you'd like to see, just give us a shout and we'll be happy to do it. Thank you very much.